last but not least will be Bruno from HPE, and he will talk about continuous packaging and how his approach or their approach helped the packaging of a system. So, until he's fixed up. Okay, cool. So, we hook up the laptop. What do you need? Just a couple of minutes. I hope you all enjoyed the DockerCon so far. Yeah? No? Yes? Did you like DockerCon? Okay. It's European cold, maybe, right? Almost there. No pressure. Okay, yeah, that looks good. Okay, so a round of applause for Bruno and enjoy the last talk.
Thank you very much. So, thank you for welcoming for this session in DockerCon. This is also my first DockerCon. My name is Bruno Kornek. I'm working for HPE. I've been working on different topics around open source for a couple of years. I'm upstream developer as well as a downstream packager. And today I want to talk to you about the packaging aspects and how to introduce a new concept as part of the CI/CD pipeline, which is a continuous packaging notion. So a lot of people are doing and automating a lot of phases during the development of their project. And they automate tests, they do gating, they do, of course, they start from a version control system and they have everything under configuration management system control. What most of the time people don't do is they don't integrate the notion of packaging of the software, Linux packaging, RPM-based, deb-based, Gen2 build, or whatever you want, as part of the pipeline, so that when you're delivering your software to your end customer, your end user, it's already ready because the tests have been done also on the packaging format, not just on the application itself. And the goal here is to show that it's possible, and I have written a tool set to help me, but the tool is not the most important. I think it's the approach which is really, really important. Why is it still important to work on packages when we have Docker containers? Because you could say, okay, my delivery means it's just an image. I put that image somewhere in a registry and everybody can use it. I still think that inside the image, you should take advantage of the packaging systems that the Linux distributions and other operating systems have provided along the years, because there are very nice advantages, such as signature management. A distribution, people working on the distributions, they have done a lot of work to ensure that there is a coherency between all the software that are brought together, that there is dependency management. So when you want to install the software, you have everything which is coming with it, ready with the right version, with the right interfaces, with the right integration level. So the guy doing the distribution, it's really an open source project to do a distribution. I'm working on that myself with other people. And it's really important to benefit from all that work, all that energy that those people put in creating the distribution, to benefit from the result and having the coherent set of packages that you inherit from the work of those guys, without talking about security management, update management, etc. So, does it still make sense to use packages at Docker age? You have a certain number of advantages by using that. First, I think one of the most important is around security and stability of the delivery of your software. So you have signature, you have checksum, which are provided as part of the infrastructure. You have the dependency management, you have metadata management, you have build procedure which are integrated. You can have patches mechanism which are completely integrated in it. LSB support, file system hierarchy support. So all those advantages are really something beneficial for you in your development of your software. So with that, what is Project Builder.org? So the goal of the tool is to make upstream project life easier with regards to packaging the software and allowing them to implement a continuous packaging approach. Well, it was more egoistically a tool I developed to solve my own problem, because everything starts with scratching your own itch. So I wanted to solve my packaging issue around my upstream project, because I'm both an upstream and a downstream developer. So what are the benefits you can expect from such an approach? Everything starts from the configuration management system. So you put your environment under a version control system, and you can put also the packaging mechanism under a version control system, which can be the same or which can be different. And packaging for me is an upstream project concern. So people should integrate that notion of building the final software in the way the people will consume it as part of the development project. It's a task that you need to do, such as coding, such as testing, such as installing as part of your project. And the smaller the project, the more important it is also from a marketing perspective to advertise your project, to make it easy to consume for your people. So the more you're able to deliver the software to your users, the best it is. And generally, when you're a small project, what is difficult is to do that on the fly. What you want as a producer of software is that a lot of people consume your software, test it as early as possible, find bugs, reports, and make your project more dynamic. And doing that from the current development, producing packages on the fly from the current status of your Git repository, Subversion repository, whatever tool you use, is really important. And there is not a lot of overhead during that, but there are a lot of benefits by implementing it in your environment, because you don't pollute your system when you install. Everything is under control of the package management. So you make a test, you have your current version, your current status of your software, you package it, you install it, you test, you remove it, everything is clean again. So that's the approach around the new mantra that I advertise people to do, which is package early, package always, and which implements a continuous packaging approach. So the goal to provide a tool which is working for you is to be agnostic with regard to the environment, because a lot of projects are using different type of tools to develop their environment. So they have different type of version control system. It could be Git, Subversion, Mercurial, whatever, CVS. And please use something, because it's 21st century, so don't use raw files. It should be operating system agnostic, so you should be able to provide packages for different targets, because you don't know who your consumer will use, what your consumer will use as a platform. They may use Debian, they may use Ubuntu, they may use RHEL, CentOS, Fedora, whatever distribution they have, a FreeBSD system, another type of system. So your packaging environment needs to be able to address all those type of targets, even if you're not an expert of those targets. And that's not only just packaging the software, but also creating the whole ecosystem around to make it easy for a deployment server to integrate your deliveries. So creating the indexes around the YAM tool or the apt-get tool, so that when your customer is using your software, it just does apt-get install, YAM install, DNF install, whatever the software is. You should be able to build for different type of environments, and Docker is the latest environment I added to the set of projects, but I started at a time where Docker did not exist, so I had to use VMs or Shroot to do the build of the software, and sometimes you need a real virtual environment, sometimes just having a type of Shroot or a type of container is just sufficient to build your environment. And one of the goals was also to have no impact on the upstream project. You should not force the upstream project to do anything, especially because you may want to package separately from the upstream project using the tool set as a separate task inside another environment. So how does it look like from a representation architecture perspective? So you have a certain number of people working on the project around the configuration management system. You have a certain set of other people, generally less numerous, working on the packaging, and they work to create information, to build the software, and to create the metadata around the software. And they are all producing two tuples that will be used. So this one is the upstream tuple from the project. This one is a specific tuple linked to all the metadata. And you pass to the tool those two tuples to produce the packages you want for the different targets you have. And in the process, you can use a local build if you are on your system to test on your system, producing your native packages for your machine, building locally, installing locally, and testing it locally. Or of course, you can create a set of Docker containers and build inside those containers for different targets, because it's very easy to build for another system than the one you're running just through the way containers are working. So how does it work concretely? Hopefully, so is it here? Okay, maybe a bit more like that. Okay, so here I'm starting from my laptop and I'm working on the project, which is still using Subversion upstream, but I'm using Git locally. So I have a Git plus Subversion version of my software, and I have a revision which is 2331, which is the current revision, the last time I made a commit into my environment. So my current version of my tool set, I will use the tool on itself to demonstrate it, has been created just this morning at 11:48 a.m. And we will now recreate a new version just to show you that if I made a modification or whatever I did in the middle, it will be able to generate a new package for it. So the project builder itself is encoding also the same version as part of the -- version option. And you have an online help, but we don't care. So what is important is here we want to make a first phase to explain how it's working. So I launched the tool on itself, and I said build packages locally on my running system, my Linux distribution, which is a Mageia distribution. You don't really care. That's not your problem. But I want to build local packages, and I ask to the system to install local packages. But of course, if I don't have any network, there are some steps which are not working correctly. So I need to activate maybe the network, if I can get my mouse back here. Okay. And that's not a big issue, because this is just the access to the repository which are not working, and my repository were up to date from this morning, so I don't need anything in addition here. What has been done through the steps is that a certain number of packages have been created, source packages for my distribution, which is RPM based, and binary packages, and those packages have been installed on the system at the time during our talk. So now if I look at the generation of the project, we see that the time is 1536, so it's a version of the package, the RPM command, which query my RPM database, sees that I have a new version of Project Builder available here, and I can check that the command itself now is also printing the same information, 1536. So we have updated our software on the fly just by using the tool to build itself. How does it work? So we have generated a certain number of files, certain number of tar files for each components of my project, and I have 5 different components in my project. I generate 2 tar files. One tar file for the component which is the upstream, and one tar file for the build information. And that way, I can have, on one hand, everything related to the upstream. So this is the tar file which contains all the upstream content. So this is a Perl application which contains a certain number of files, libraries. And then you have the configuration, which is separate. And the configuration here has been created using the configuration file for the running distribution, which is Mageia 6 in my case on x86-64. So I have a certain number of Docker images on my system, which are already pre-built for different distributions throughout the time. So the project exists since the last 10 years. So now I have a certain number of existing Docker images that I use to build. And each time you have an image, Fedora 23, x86-64, it has a certain number of suffixes that are created by the tool to say that the image has been made with Project Builder and targeting a certain project to build, because it needs to have dependency information in it to be able to build correctly the software. So all that is created by Project Builder. I won't do it here because we don't have a lot of time to do it live, but that's something which is also part of the project. So do I have some network? Because for the next phase, I would need a bit of network available. That would be better. So I can ask to build for another distribution, for example, the Fedora distribution, in which case I take the same build files. Here I'm remaking them, that's not mandatory. And I pass a certain number of configuration files plus the tar files to the Docker container. The Docker container has been called, the build has been done in the Docker container, and at the end of the operation, we are generating, in the container, we are generating the packages using the build procedure, which is part of the container, and that distribution, but we are also generating the indexes for, in that case, the YAM repository. So if we look at what has been generated, we see that we have here the last package which has been generated just now, 1540. So we see all the RPM packages, source packages available, but we are also generating a repo file for YAM and the repo data information, as well as signing information with a GPG key, so that you can install the packages directly using what has been just generated on the fly from your Git repository or here the Subversion repository. So you can create a small Dockerfile here typically to say, okay, now I want to use that software that I just generated. So I will wget the repo test. I will just modify the pointer to the repository to make it local and not distant as I do usually. And I will install my software in that Docker container and run the application just to see that it's working correctly. So I connect to my local environment. I download the repo file. And now I try to install it, and if I have no network, of course, there is few chances that it will install because it needs a certain number of dependencies which are not part of the standard image. So the way it's working is that we use the standard upstream container image provided by the distribution, and we just enrich it with what is needed, so by project builder, to have all the tools necessarily to create the environment. So here, of course, it will not be able to install. I can show you with a working network how it's working. So it will download, in fact, all the dependency from the Fedora repository, and the rest will come from the local repository, which has just been generated before. Okay, let's go back maybe to... Okay, so there are a certain number of goodies. All those Docker containers are created on the fly, so the Dockerfile are generated by the tool, and everything is built and can be completely automated as part of the process. There are a certain number of macro mechanisms. I've shown to you the repository management. So the way it's layered is that there is a first Docker image that you create from the existing distribution image upstream. You just install in it the project builder dependencies because the build is always local inside the container. And then for each project that you want to build, you create one image, which is based on the previous one, which contains all the build dependencies for the projects that you want to target. And once you have that, you can instantiate a container in which you will build the software each time you need to build it. So that's the way it's organized. I have a couple of web resources that you will get in the presentation, and I think we are just on time to finish. Yeah. Yeah. And thank you.
Yeah, thanks Bruno. And this concludes our community theater. So thanks guys for attending. I hope you liked it, and yeah, a hand for Bruno again.
Thank you.